Hello students, today's my topic is properties of Fourier transform. It is the topic of signal and system subject of third semester and it is my lecture of one for this subject, and this is very important topic of signal and system, and the RGBB ask many of questions from this topic. So please student learn very carefully and note down in your notebook. So first of all, these are the 11 properties of Fourier transform, and highlighted properties in the red color are the very important properties. These are the time shifting property, frequency shifting property, time convolution, frequency convolution, also called the modulation property, Parseval theorem, and the duality. Although all the properties are important, but these six properties are very important, and the questions will come from these properties. Very important questions are there. We will learn questions also. So the first property is the time shifting property or the frequency shifting. Time shifting means if in the time domain the signal is xt in its Fourier transform of x of omega, then if t is shifted to t0, you know the shifting. All of you know the shifting of time. If the time is shifted to t0, then its Fourier transform in its Fourier transform e raised to the power minus j omega t0 will multiply. Means a shift of t0 in the time domain is equivalent to introducing a phase shift of minus omega t0. But amplitude remains the same. Amplitude is remains same, but the frequency domain signal is multiplied by e raised to the power minus j omega t0. You have to remember this property as it is. And then the frequency shifting. If any signal in the time domain is multiplied by e raised to the power j omega 0 t. How it is frequency shifting? Because we are multiply with the e raised to the power j omega 0 t, which in turn is the sine and cos. You know the Euler's theorem. So what will be the change in the Fourier transform? In the Fourier transform, x of omega will shift it to omega 0. X of omega minus omega 0. So it is the frequency shifting property. Time convolution. Convolution in the time domain means if there are two signal x of t and h of t, and the convolution of x of t, h of t is convolved, then what will happen in the frequency domain? In the frequency domain, simple multiplication of both the signal. Simple multiplication of both the signal in the frequency domain. So if the convolution question will come in your paper, then you can solve in this way also. You can determine the Fourier transform, then multiply simply in the frequency domain. So in this way, you can also calculate the convolution. We will learn the convolution, what is the convolution in the further chapters. The fourth one is the frequency convolution. In the frequency convolution, if there are two signals which are multiplied in the time domain, there are two signals multiplied in the time domain, then what will happen in the frequency domain? In the frequency domain, they will convolve x of omega convolution y of omega multiply by 1 by 2 pi. Parseval theorem is very important. Many of the question in the RGPP papers will come from this topic, Parseval theorem. In the Parseval theorem, you know what is the formula of energy. We can calculate the energy. There is a formula minus infinity to plus infinity x of t modulus of x of t whole square of tt. Then how will we determine the energy of these signals in the frequency domain? 1 upon 2 pi minus infinity plus infinity x of omega whole square. So in this way also we can calculate the energy of signal if the frequency spectrum is given or the Fourier transform of given signal is given, already given, then no need to inverse Fourier transform, only just use this formula to calculate the energy of signal. Duality theorem is the very important. If x of t Fourier transform of x of omega, then if we change the variable x of t, capital X of t, omega, in place of omega we write the t. So in place of t we will write the minus omega and 2 pi x, and the 2 pi multiply by 2 pi, and in place of t we will write the minus of omega. Just we replace the variable, we interchange the variable. So these are the questions based on the property of frequency shifting. In this property, we will calculate the Fourier transform of e raised to the power j omega 0 t, which is the 2 pi del omega minus omega 0. So in this way, you can calculate the Fourier transform of cos omega 0 t. That is the periodic signal. So periodic signal, we will write in this periodic signal in the form of Euler's theorem. And after the Euler's theorem, it will convert in 1 by 2 in the fourth step. You can see minus infinity to plus infinity, e raised to the power j omega 0 t, e raised to the power minus j omega 0 t. So this is the Fourier transform of e raised to the power j omega 0 t, which is multiplied by e raised to the power minus j omega. So in this way, we will write the Fourier transform 1 by 2, 2 pi del omega minus omega 0. We will solve this question in the class also. So first of all, you will write these 6 properties in your notebook and learn. Thank you.